is page 380, number 14. So we have this function here, and they want us to show that the second derivative is positive for all x except those whose absolute value are less than or equal to 1. So recall that this is just another way of writing -1 less than or equal to x less than or equal to 1. So we need to show second derivative is positive for all x values except these. Okay, so let's start by finding the second derivative. Okay, which of course we do by finding the first derivative first. So here I have to use the chain rule. So the derivative of ln u is 1 over u. So 1 over this expression here. Okay, so that's the same thing as saying the reciprocal of this expression. Okay, so I'm just going to go ahead and skip that step and go straight to writing x squared minus 1 over x squared plus 1. Okay, so x squared plus 1. Okay, and then of course I have to multiply that by the derivative of the inside, which is going to require the product rule. So derivative of the top, 2x times the bottom, x squared minus 1, minus the top function, x squared plus 1, times the derivative of the bottom, 2x, all over x squared minus 1 squared. Okay, so one thing I notice here is I have an x squared minus 1 in the numerator that I can reduce with one of the ones in the denominator here. Okay, so let's simplify this here. So I have a 2x cubed and a minus 2x cubed. Okay, so that'll cancel out. And so here I'm left with a negative 2x minus 2x. So I'm left here with negative 4x alone in the numerator, all over x squared plus 1 times x squared minus 1. Okay, so here I have the first derivative, so I need to find the second derivative. Here, hopefully you might notice that I can simplify this here, because if I leave it as is, when I take the derivative of the denominator, I'm going to need to use the product rule. But if I just multiply this out, you hopefully recognize this as just being a difference of squares. Okay, so this is just going to give me x to the fourth minus 1. Okay, so this makes it a little easier to deal with. So let's take the second derivative now. Derivative of the top, negative 4 times bottom, x to the fourth minus 1, minus negative 4x times derivative of the bottom, which is 4x cubed, all over x to the fourth minus 1 squared. Okay, so let's simplify here. So we got negative 4x to the 4 plus 4. And here we have plus 16x to the 4. Okay, so when we simplify this here, negative 4 plus 16, so we have 12x to the 4 plus 4 all over x to the 4 minus 1 squared. Okay, and we see that this expression here is always positive. Since the numerator is always going to be positive, the denominator is always going to be positive. Okay, and so we have here that this is greater than 0. Okay, now given what we're seeing here, I'm not seeing that restriction that they gave us. They're telling us to show that it's positive for all values except when x is between negative 1 and 1. Okay, so we're going to have to figure out how that comes into play. And this is where now I'm going to go back and look at the original function. Keep in mind that we have restrictions on logarithmic functions. Okay, the input to a logarithmic function can't be less than or equal to 0. Okay, so let's actually find the domain of this function. Maybe that's where it comes from. Okay, so what I want to do here is I want to find the domain, okay, of y equals ln of x squared plus 1 over x squared minus 1. Okay, so since it's a logarithmic function, I need x squared plus 1 over x squared minus 1 to be strictly greater than 0. Okay, now the numerator is always positive. Okay, so that means I need to determine where the denominator is also positive. Okay, notice here that we do have the restriction that x can't be equal to 1 and negative 1. So we've already satisfied the endpoints of this interval, meaning They can't be included in our answer. So here we need x squared minus 1 to be greater than 0 in order to make the whole fraction greater than 0. And here, if I just draw a quick sketch and I see that that's x squared minus 1 looks something like that, and it's greater than 0 when x is less than or equal to negative 1. Okay, actually, sorry, just less than negative 1 because we need it to be strictly greater than 0, and when x is greater than positive 1. Okay, so we've shown that the second derivative is always positive, and we've also found the domain. So the domain is just x in R, okay, such that x is less than negative 1 or x is greater than positive 1. And we've shown that on its domain, the second derivative has to be positive, hence we've satisfied all the conditions. Okay, so y double prime is positive on the domain of y. Okay, and there we go. There we have it. Okay, so let me just do a recap here. I think panning out might not work. So again, what did we do? Found the first derivative, found the second derivative, showed that the second derivative had to be positive, and then I showed that the only x values that are valid are those which are outside of the interval -1 to 1 inclusive. Okay?